Hello. Physical science learners and teachers alike, and anyone interested in the knowledge of the subject. Another session. Let's focus on electrochemistry. In the next two questions, we'll try to clarify issues and maybe explain much better in our quest to make physical science very interesting and to learners very simple. So let's start with your galvanic cell. In the recent question paper, here is the question number 8. They are telling us to say the following balanced chemical equation represent the reaction taking place when a galvanic cell is in operation under standard conditions. You see, it's now in upper cases, standard conditions. Be careful that. Remember the conditions under standard. The initial reading on the voltmeter is 0.14. That's your EMF when the salt bridge is connected. There's an equation there. From this equation, you can even clearly analyze. If you can just get closer, you can see that 6Cl minus, which is chlorine ion, and then the 2 gold ion, and forms 3 chlorine gases, 3 moles of chlorine gas and 2 moles of gold solid. You can look at from this one, you can tell that from in terms of oxidation numbers from -1 to 0, therefore it means that now this is oxidation. There's an increase in the oxidation number. That's oxidation. Therefore chlorine ions are oxidized to form chlorine gas. Then mean that the Cl minus will be our reducing agent. And then also we look at the gold here. We see that now from 3 plus to 0, therefore that's decrease, that's reduction. Now we can see that therefore Au3 plus will be the oxidizing agent. Fine. Right, 8.1 they say write down 2 standard conditions under which this cell operates. Remember, as long as we've got a gas, then meaning that now platinum will be one of the electrodes here. We'll have gold and platinum on the other side. Therefore, all 3 standard conditions are applicable in this cell. Therefore, they say any 2. Then you can just write any 2 out of the 3. So, the temperature should be 25 degrees Celsius. We can just remember, just write 25 degrees Celsius is fine. And then concentration of the electrolytes, should be 1 mole per dm cube. Fine. And then the pressure of the gas, chlorine gas here, should be 1 atmosphere or 101.3 kilopascals or 100 kilopascals. All the 3 are acceptable. So you can just write any 2 out of the 3 conditions. Fine. 8.2, they're telling us to say, fine. For the cell, write down the number 1 name or formula of the electrolyte that can be used in the salt bridge. Remember, salt bridge, we need an ionic compound. In this case, we can use any nitrate, potassium nitrate, sodium nitrate, or just say any soluble salt. Any soluble salt can be used in the salt bridge. Yes. 8.2.2. On this one, they say now write down the reducing agent. Reducing agent will be the one that undergoes oxidation, which will be your Cl minus. Just write Cl minus. Therefore 8.2.3. on this one, write down the cell notation. Very important. Cell notation, remember we said the chlorine ions are oxidized, therefore we'll start with the chlorine half cell. Therefore, because there's no electrode there, hence we'll be starting with platinum solid, and then Cl minus, which is aqueous, and then Cl2, which is a gas, salt bridge, and then we'll have Au3 plus solution, and then Au, which is a solid. So remember, this acceptable just to write without the faces here, but this is the perfect one that you can do. So out of this one you'll get the 3 marks here. Fine. Remember, 1 mark for the salt bridge, 1 mark for the correct oxidation site of the cell, and then the correct change in the reduction half cell. And fine. 8.3. Now 8.3 we are calculating. Now they say calculate the standard reduction potential of air gold. What we do for 4 marks, we just have to write the EMF, because the EMF is given. We'll write the formula. EMF of the cell equals to the electrode potential of the cathode, or where reduction takes place, and the electrode potential of the anode, that's where oxidation takes place. EMF is given, according to this is given in the statement, 0.14. And then the cathode we know is gold. Then we can just write the electrode of the gold, Au, and then minus, this will be that of chlorine. Chlorine is plus 1.36 from that one, and then therefore electrode potential of the gold will be, if you use maths, this plus this one will be positive 1.5 volts. That is the 4 marks that you'll get. That put the end of our question number 8. We can move to question number last, which is the one of electrolytic cell. Electrolytic cell, remember, galvanic cell is exothermic, energy is released there, and then whereas electrolytic cell is endothermic. So here in question number 9, we are dealing with the electrolytic cell. Now they're telling us to say, remember, there are 4 cells that are examinable. We are given 1 cell here. Simplified diagram below represent the electrolysis, which is a process anyway of a concentrated sodium chloride solution. Fine. According to this one, they're telling us to say, we can analyze this one before even answering this question, to say, look at positive, negative. Therefore, the negative electrode, it will be our cathode, that is Y. Remember, it's a carbon electrode. Therefore, Y in the cathode, that's where hydrogen will be formed. And then in the anode, the positive electrode, that's where chlorine will be formed. Fine, no problem. Therefore, X is the anode, Y is the cathode. Fine. The equation for the reaction taking place in the above cell is this one. So this one included the spectator ions. Fine. Water forming this one. So already you can see what's happening there. Define the term electrolysis. Remember, electrolysis, there's a difference between electrolysis, there's an electrolyte, and electrolytic reactions. I hope you know the difference between the 3. So electrolysis is a process. So it will be a process whereby electrical energy is converted into chemical energy. So otherwise we can state it anyhow. A process whereby chemical reaction is forced using electrical energy. Fine, no problem. 9.2, which electrode is the anode between X and Y? We have already said the anode is the positive electrode, which will be X. Fine. 9.2.9.3.1 now. Okay, if they were saying give us the reason why, you just say oxidation takes place or is the positive electrode. 9.3.1, which write down the half reaction that takes place at X. X, that's our anode, that's where chlorine will be formed. Go to the table and just copy the reverse reaction, which says 2Cl minus will form Cl2 plus 2 electrons. That's the case, you get the 2 marks. Remember the rule in marking this one. Fine. We come to the half reaction that takes place at electrode Y. If you go to that one, obviously you see the other one is coming from the 2Cl minus forms Cl2 plus 2 electrons. This one will be water now plus electrons forming 2OH minus and H2. So now this is the reduction. It will be 2 water molecule gaining 2 electrons and forming hydrogen, a gas plus 2OH minus. Remember, they can even ask you this question of saying why hydrogen is formed at the cathode, not sodium. So you will be looking at the oxidizing abilities of water and sodium ion to say water is a stronger oxidizing agent than sodium ions. Therefore, water will be reduced to form hydrogen, or sodium ions will not be reduced to form sodium. So that is the nice question that can be at least giving you more marks in this section. Now let's go to 9.4. They are saying to us, it's usual these days that you'll be featuring stoichiometric calculations here, which featured very important the calculations in chemistry and physics in one question. So this is done for 6 marks. They say a current of 0.5 amperes is applied over a period of 5 hours. Current, and this one, remember, they'll give you the charge. Calculate the volume of chlorine gas at STP. Remember STP, the molar volume is 22.4 decimeter cube. That is formed during this time. For no problem, we start with this one, current and time. So current and time according to paper 1. If I've got current and time, then we'll find the formula that the charge equals to current multiplied by delta T, which is the same as, in this case, 0.5. That is the current. Time, it's 5 hours. It will be 5 multiplied by 60 multiplied by 60. An hour is 60 minutes. A minute is 60 seconds. I think that's how it brought about, which will be around 9,000 coulomb. That is the total charge. Now, no problem. Once we have got a charge, we can now still in physics calculate the number of electrons. Remember, the formula says number of electrons equals to charge over elementary charge. You can write E or just write Q over QE. So both they mean one and the same thing. Charge is 9,000. 9,000 divided by elementary charge is 1,6 by 10 to exponent minus 19. Therefore, the number of electrons here will be 5,625 by 10 to exponent 22 electrons. Now, this will be the number of electrons in that charge, this one of 9,000. Now, if we know the number of electrons, remember we can go back and now say the moles, because we don't worry about number of electrons. Now we move to chemistry. We need to talk about mole. So the number of this one, the moles of electrons, number of moles of electrons, we are using now the Avogadro now, N over Na. Therefore, the number of electrons is the one that we just calculated, 5.625 by 10 to exponent 22, and the Avogadro's number is 6.02 by 10 to exponent 23. Now the answer here, you get something like 0, 0.093 mole. Fine, now we have got moles. We can go back to the equation and say, according to that equation, remember this equation, what's happening in the chlorine half reaction, then the moles of electrons to chlorine gas 2:1. Therefore, the number of mole of chlorine is half of the number of mole of electrons. Therefore, you can just say number of mole of chlorine gas equals to half of the number of mole of electrons. So fine, which will be half of multiplied by 0.093. Then the answer here will give us 0.04, in this case 65 mole. This is the mole of chlorine gas. Now if you know the mole of chlorine gas, it's very easy now to calculate the volume. We go back now to the mole stuff to say, if I know moles, I can always calculate. In this case, what will be the case? To say, now the number of mole of chlorine gas will be the same as the volume of that chlorine gas divided by the molar volume. So the volume of chlorine gas now, which will be this, will be now 0.0465 multiplied by the molar volume, which is 22.4. Or you can just remember, go to this one and say, if you move from here, you just now have 0.0465 equals to this case V over 22.4. So if you want to substitute that way, so in all these cases, the volume of the volume of chlorine gas will be 1.04 decimeter cube. That is the final answer. Very important if you are using stoichiometric calculations. Once you find the moles of electrons, you can find the moles of the substance that is in the question. Sometimes you find they say we have got the mass, then you move from the mass of that solid that is accumulated at the cathode and then go to number of moles of electrons. So be able to use half reactions to deal with moles or stoichiometric calculations. I think this brings us to the end of these two electrochemistry questions. Very interesting and very I hope it was well explained, and if you can meet similar questions, hopefully you'll express yourself. So it's all based on what is given, and then the mole is central in chemistry, remember. So we always calculate when we've got a balance equation, we normally relate using moles according to the mole ratio in the balance equation. So we'll meet also in other sections similar to this one, so that we prepare you well for the upcoming examinations or upcoming tests or upcoming assessments, so that this section of electrochemistry or the physics in general becomes very easy and if well explained. And that's the case, keep on watching and don't forget to subscribe, and don't forget to spread the word of saying these are the videos and then where learners are benefiting a lot. Let me also be part of the ones that are benefiting out of these explanations very well. In this case, I hope you enjoyed it. So until we meet again in the next session, keep it up and good luck. Thanks.